Thank you for coming. It's a pleasure to be here, and it's a pleasure that you selected my speech. I hope I can deserve your trust in me. Today, I'm going to talk about a topic called how to break the software. First of all, thank you for Attila for intro. My plan was to do some sort of introduction of myself, so I'm going to quickly skip this slide because I don't want to repeat myself. So, as you heard, I have like 20 years experience in software engineering, and I'm one of those very few who accidentally become a software tester. My life is full of accidents. I wanted to work for Nokia, never worked for Ericsson, and I ended up working for Ericsson for 16 years. I always wanted to be a dev. Never wanted to be a software tester, but when I was 21, I got an offer from Finland, Helsinki, to become a test automation engineer. And I had no clue about test automation, trust me. All I wanted was to work abroad. So I accepted the challenge, and software testing quickly became my passion, fortunately. And as you can see, I'm still passionate about software testing, speaking at conferences, trying to share my experiences with you guys. I'm working for this company called NNG, and we develop car navigation software. And most of the time, I'm focusing on process improvement, process assessment, efficiency and effectiveness improvement, tool selections, and data analytics. And as you can see, I'm still trying to kill bugs with my laser eye. So in the first row, be careful. You never know. So that's all about my intro. Let's see the topic I brought you. So it's how to break the software. And this presentation is about demystifying a myth. I'm going to talk about the myth I had when I was young. When I was young, I was always dreaming about becoming a superhero. You know, I wanted to be like Superman and fly, and be as fast as Flash, or be as strong as, Hulk. And obviously, it never happened. I never became a superhero. When I started my software testing career, I was watching those seasoned testers with 15, 20 years of experience. And I thought, oh my God, what they do is magic, because they were able to quickly spot those tricky scenarios that are worth to test. But after spending 20 years in this business, and I know it's not magic, so we all have a sort of superpower, so to say, so we testers do have this X-ray eye, or we can improve our skills to become a superhero of software testing. So this presentation is more about showing you an approach, how to become a better software tester, how to improve your skills, how to analyze your requirement basis and your technical specification to identify those tricky aspects and scenarios that are worth to test. So that's the whole idea. Basically, the topics I'm going to cover is not going to be new for you, because you studied computer science at the university. So trust me, it's more like revisiting certain topics. So when I was a young tester, I saw these people doing that magic, And 20 years later, now I know it wasn't magic. First of all, those people simply had previous experiences with the same product, obviously. So it's an obvious pick. Secondly, they had previous experience with the same domain. Like I have 16 years of experience in telecommunication, so I have a greater chance to identify those tricky scenarios when it comes to telecommunication product testing. It's obvious, so it's no magic. I have 16 years behind me. Then obviously those people may have previous experiences with the same technology in use, architecture design, and obviously they knew the users, their behavior, their expectation better than me. So now I know that's why it's so important to continuously learn. And I propose to people to revisit certain topics, because after the second read, after taking the second time the same training, you will still find valuable information. So what else we got? Fault model. As I said, I truly believe that in today's competitive environment, we do need to use strategies and approaches to tackle with the challenges. We need to develop complex software within a short time with the desired quality. And it's challenging. So if you do ad hoc testing, ad hoc software engineering, you won't succeed. Trust me. And this is an approach I would recommend you to use. It's an approach that shows you what sort of aspects you should consider when you analyze your requirement basis and technical specification, so to say. So this is the default model, I called it. Your product is in the middle, in a gray box, system under test. And let's see what the three perspectives are, what we are going to discuss today, because this model I've created has 3 dimensions. First of all, it's quite an obvious pick, the operational environment. Your software obviously runs an operating system, a middleware, uses different I/O devices, yes. We have often third-party systems your software interacts with, and you also have users who interact with your software. They can be human beings or a computer. So these are the aspects we usually cover, and there's one trick here most people miss. Usually, I/O devices don't communicate to your software directly. You have the operating system in between. So this is the ID. This is the perspective we should consider from operational environment point of view. Then we have internal architecture, yes, and capabilities. And let me go through all these 3 perspectives. We are going to focus on most the operational environment. Due to the limited time, we will just quickly cover the other 2. So, operational environment. In many cases, your product is supposed to operate in a diverse operational environment. Let me explain what I mean. So, if you develop a mobile app, you're supposed to run smoothly and look nice on all sorts of screen sizes, run on different operating systems, and run in different browsers and display messages in local languages. Just to mention a couple, this is not all. But you can imagine how difficult, how complex it is to implement a software that works smoothly and properly in this diverse operational environment. And if something is challenging to implement for the devs, trust me, you have a great chance that you are going to find issues. And if you identify those tricky scenarios, you are going to catch bugs in the software. I brought you a couple of examples from my career. Let's start with the first one. It's from the time when I was working for Ericsson. And we developed the telephone exchange. And we had this web-based toolbox to do the administration stuff. And we tested in all sorts of browsers for a good reason. One day, we had the following scenario. So we tested in a specific browser, and after the admin logged out, anyone could log in by simply pressing the back button. And just imagine what kind of threat it is. Anyone could gain access over the mobile network with the back button. Scary, right? And could access your subscriber data, actually. And we have found it because we considered this diversity aspect of the operational environment. So I would recommend you the same. If you have this diversity factor, consider it during test design, and when you identify those aspects you would like to test your software from. These days, we develop car navigation software. And it's very challenging because in this case, we have a so-called geographically diverse operational environment. Let me give you a couple of examples. Left top corner, tunnels. In Austria, you have several miles-long tunnels with multiple exits. Still, without GPS signal, your navigation software is supposed to navigate you to the desired destination, right? Then, you have skyscrapers in New York City, and often between the skyscrapers, you have no or just very weak GPS signal. But you, as a car driver, expect the navigation software to navigate you to the desired destination. Then in the US, you have multiple locations where you have these multi-level highways. But the navigation software is still supposed to know on which level you are driving a car and drive you to the right direction. And last but not least, bottom right corner. Guess what it is? Actually, it's what they call in India traffic. As you can see, no traffic lights, no lanes, and no house numbers. But still, you're supposed to be navigated to the desired destination. So it's a challenge for us, and we often find bugs in the software in those specific areas connected to this diverse geographical environment. So these were my examples. Let's see what else we have. Obviously, we have users. As I told you, the more diverse your user group is, the more diverse their requirements, their behavior is, the more challenging it is to implement the software, and thus you have a greater chance to find bugs. Obviously, if you have a quite homogeneous user base, like Linux users, mostly professional people use Linux, not my mom. So then you are in quite a good position. But otherwise, it's quite challenging if you have a wide range of users, like GPS. My mom can hardly turn on my Apple TV. Still, she's supposed to be able to use the navigation software. So it's a challenging thing. Then, what else we have? So we often forget about, but our software uses resources like memory, CPU, remote resources, and file storage. When we were developing this telephony exchange, we often tested scenarios like hardware failure of a component. Why? Because this telephony exchange is supposed to operate for 15 years uninterrupted. So we're supposed to consider hardware failure scenarios, low resource scenarios, and stuff like that. And we often found bugs, when we tested this sort of scenarios. Then, this is a true story. I have an NDA, so I can't name the Hungarian operator who escalated this. But one day we had an escalation, part of the network went down. So no phone calls, no internet for several hours. And after a quick investigation, we found that some smart guys, so the admins of the mobile operator, run a video sharing service inside the company, which made the disk space to run out and the system go down. So, like several 100,000 people couldn't talk because these dudes wanted to share some videos inside the company, practically. At that point, we thought, lucky us, it's not our fault. Guess what? It was, actually, because we forgot about this scenario, because we're supposed to send the warning to the admin that, hey, Jude, you are running out of disk space, which we didn't do, because at least I forgot to consider this aspect. And it cost the company a lot, because we're supposed to pay $25,000 US per minute. So you can quickly calculate. Probably this was the most costful failure of mine in my whole career. Yes, what else we have? Obviously, we have remote resources. As I said, like remote database servers, other systems your system interacts with during operation. Obviously, they may not respond. They may respond slowly, run out of resources, etc. That was all about the operational environment. I'm going to go through quickly on the other two dimensions. And starting with capabilities, I'm going to spend just a little time on capabilities because most of us focuses on this aspect most of the time. So obviously, we play around, test functional, non-functional behavior, and we play around input-output behavior, right? Because practically, your software is supposed to accept input, perform computations, store data, reuse them, and produce output. So it's simple, all software does this. But I have created this mind map just to show you a couple of those generic scenarios we usually test. Obviously, we test functional, non-functional behavior, yes. And we are not only test standalone features, but often interworking, because they may interact, because they may use shared data, or maybe a state machine is involved, right? And obviously, we test negative and positive scenarios. And I brought my favorite example on the bottom, triggered single pass, multiple pass. So it means often your feature can be invoked from several places. And guess what? Sometimes they don't behave the same. So don't miss those sort of testing. Don't think if you can invoke feature from the menu, if you triggered by a short key, the same will happen. So I think it's worth to test. Let me see what we have, architecture. That's the third and final perspective.